Alright class, this is the last video before your quiz. It's solving absolute value equations and inequalities. First of all, we're going to just talk quickly about what an absolute value is. And again, an absolute value helps represent the distance away from zero, and it's always positive. Okay? Now, when you solve this, it says please solve each absolute value equation and then give your answer in set notation. Well, we are going to do that. When you solve these, you get two equations, usually, and you want to first isolate the absolute value on one side. Okay? So if we look at number one, it is just the absolute value of something equals 22. First of all, can we get a positive 22 out of an absolute value? Yes, because the absolute value is always positive. So here's what can happen. We can have 5m plus 7 is equal to 22, or we can have the opposite. And then actually I'm going to write this on the side next to it. We can have the opposite. So when you have the opposite, now you can solve each one, because we can either have the negative of that in there or the positive, and either way it should give you a positive 22. So now we just solve. 5m equals 7. 22 minus 7 is 15. So m can be 3. Divide by negative, we get 5m plus 7 is equal to negative 22. So when you subtract 7, you get 5m is equal to negative 29. So we get m is equal to negative 29 fifths. Okay, so we have m equals that and that. Now, since absolute values have domains of all real numbers, these are both real numbers. So we would say, set notation, these are both solutions that would work. If you plug them back in, you will get a 22 for your final answer. So they both go into the brackets. So number 2 is not set up nicely for us yet, so we have to first isolate the absolute value symbol. So I'm subtracting 16. So we get 4 absolute value of 3m plus 1 is equal to negative 8. Divide by 4, and you get 3m plus 1 is equal to negative 2. Is there any way that this side will ever be a negative 2? Hopefully you guys are looking at it and saying, well, no, because these bars are going to make whatever's in here positive. So then there's no way that could be a negative 2. So this would be no solution. You can either write no solution, or you can give me the no solution symbol. Do not put the no solution symbol in brackets, because then you're saying there's no solution to there's a solution to a no solution. All right, let's do 2 more. Again, isolate. So we move that over. We get negative 6 is equal to negative 2 absolute value of 9 minus x. Divide by negative 2. And you get, 3? Now you analyze, is there any way to get a 3 out of an absolute value? Yes, you can get positive values. So we now break it down to 2 equations, the original, 9 minus x equals 3, or the opposite. So when you solve this, you get 3 minus 9, which is negative x equals negative 6, or x equals 6. Over here you get 9 minus x equals negative 3 minus 9. Negative x equals negative 12. X equals 12. So if I put that in brackets, we have the answers of 6 and 12. Okay. Over here, again, try this. Maybe pause the video here and try this one on your own before you watch it. Come on, guys, pause the video. Alright, now you can unpause. So we move that over. We get negative 3. X plus 8 equals, if you add 12 to a negative 12, you get a 0. Divide by negative 3. Alright, so now this is where you're going to see what happens when you have something equal to 0. Okay? Some of you guys might already know what happens by looking at it, but let's do our 2 equations. So we get x is equal to negative 8, and we get that x plus 8 equals 0, and x equals negative 8. So when it's equal to 0, there's only one value that will get you to 0, because you can't have a negative and a positive 0. So there's only one solution, and it's negative 8. So, can the following happen? And we just showed this one. Can you have a bunch of stuff equal to 0? Yes, but there will be one solution. Okay, because you can't have a negative and a positive. Can the absolute value of x be greater than 0? Yes. The absolute value makes everything positive. What about, can you have an absolute value of something less than 0? Hopefully on this one, if this number was like -4, you would say no, because the absolute, again, the absolute value sign makes the expression positive, so no way to get a negative number. Okay. All right, let's go on and start doing absolute value inequalities. When you have an expression with a greater sign than a number, excuse me, we would say that this is greater. If it's greater than the number, so it's going to be an or. If it's set up and after you do everything it's isolated and it's smaller than the number, we would call this less than. And I'm going to say less than so you know it's an and, okay? So, yeah, that's pretty much it. Make sure to isolate. I don't know why I have those boxes there, I forget. So, that's all you need to know, really. So let's do this. Same method, though. This is already isolated. It's going to be it's going to be an and graph. And then I'm going to do my inequalities the same thing I did the other ones. I have 23 minus 2x is less than 17. And then I have negative 23 minus 2x is also less than 17. When you divide by a negative in this case, it will end up flipping the symbol. So be careful with that. It always will happen for the second piece. So I get this one, I can just start subtracting. Negative 2x is less than negative 6. And since this is going to be an and, I'm going to put an intersection symbol there. I divide by a negative. I get 23 minus 2x is greater than negative 17. I'm going to keep solving both sides. I get x dividing by a negative is greater than 3. And I'm going to intersect that with, I'll keep working on this one. This you get negative 40 on the other side. So my final answer is x is greater than 3, intersect with x is less than 20. And sure enough, if you graph that, it should look like an and graph. So I have 0, 3, and 20. If I do this piece first, x is greater than 3, x is less than 20. Sure enough, with an and, you look at the overlap between these two values, that will satisfy the inequality. Okay? So you work them the same way as solving, except for you have to be careful with flipping the inequality symbol every time you divide or multiply by a negative sign. Adding and subtracting does not. So let's move that over first. So we have absolute value of 4x plus 5 is greater than or equal to 7. This is an OR graph now. Okay, so I have my two equations. 4x plus 5 is greater than or equal to 7, or I have the opposite is greater than or equal to 7. When I divide that one by a negative, it'll flip it. 4x is greater than or equal to 2, or 4x plus 5 is less than or equal to negative 7. This becomes x is greater than or equal to 1/2, or you get 4x is less than or equal to negative 12. So our final answer is x is greater than or equal to 1/2, or x is less than or equal to negative 3. If we graph that, it should look like an OR graph. So 1/2 is here, 0, negative 3. Filled in bubble, x is greater. Filled in bubble, x is less than negative 3. take both pieces for our OR graph, and sure enough, this is our full solution set. Alright, let's keep going. We have to analyze some more. 22 minus 4 is 18. Okay. Divide by a negative. When you divide, you have to flip the symbol. Now here's the tricky one. Again, we have a negative on this side. Now with inequalities, you can have a negative on this side as long as this side is greater. But if you look at the symbol, it's saying, well, where are the x values where this side will be less than negative 2? Well, the absolute value will always give you a positive. So will this side ever be less than negative 2? Hopefully you guys say no. This would be a no solution. Okay? Can't have, this has to be positive. So I'll write positive. Alright, last problem. Move the 8 over, so we get negative, what, 27? Divide by 3. And that becomes negative 9. Now, we have a negative on this side again. However, notice the symbol. It says, are there x values where we're going to be bigger than negative 9? Well, yeah, because we're eventually going to get into the positives. There are x values that will make this positive and bigger than 9. So this is okay. This is an OR graph. Now we can solve it the way we've been solving. The one side is x minus 7 is greater than negative 9. The other side is the opposite of x minus 7 is greater than negative 9. So we solve. X is greater than, add 7, negative 2. Oh, this should be an OR. X minus 7 is less than 9. Then we can move that one over. We're already set with this one. Okay. So x has to be greater than negative 2 or less than 9 or less than 16. So when x is like negative 1, well, let's see what happens actually, because honestly, we did all this work and look what will happen actually. When you graph these, remember it's an OR graph. Greater than, less than. But remember, this is usually an AND graph. So with an OR graph, you take all the pieces, and this is basically saying anything you put in will be a solution. And it makes sense. Anything you put in here will either be positive or a 0. So anything you put in will always be greater than negative 9. So we should have gotten all real answers anyway, which we did. But you can check with that one. This one, you would also, if you want to, you can go through it and see that it's no solution. But that one is easier to spot. Alright, so that is how you graph absolute value inequalities and solve absolute value equations.